everyone, welcome back. In this particular video, we will be discussing the problem GCD of array from DSA basic math category. What is the problem? Given an array of numbers, there will be a lot of numbers, not just two numbers, array of numbers. What we have to do with them? We have to find the GCD of all the array elements. GCD of A1, A2, A3, A4. Let's suppose if A1, A2, A3 are the array elements. What is GCD? GCD is the greatest common divisor. Greatest common divisor, or also known as highest common factor. So GCD or HCF of two numbers is the largest positive integer, the biggest integer, which will divide both the numbers completely, evenly. It means it is able to divide both the numbers. It means it is a factor of both the numbers. If it is GCD of numbers A and B, the answer GCD should be a factor of both A and B, but it should be the largest possible such factor of both A and B. That's why it is common. Common means both. Largest means greatest, or you can say G, and D means divisor, or you can say factor. So all the three things should be there: greatest, common, divisor. But we don't have to do it for just two numbers. We have to do it for n numbers, where n is the array size. So let's take the sample input. Sample input is very easy actually. There are four elements. So what are the four elements? There are n is equals to 4 values present in the array: 4, 6, 8, 16. 4, 6, 8, 16. What is the GCD of all of these numbers? GCD of the entire array. GCD of entire array will be the common divisors for all of these numbers. What are the factors of 4? 1, 2, not 3, but 4. Only 3 factors. What about 6? 1 again, 2 again, 3 also this time. Not 4, not 5, but 6. What about 8? It will be having 1, 2, not 3, but 4, and then simply 8, not 5, 6, 7. What about 16? We will have 1, again 2, but not 3 this time. We will have 4 for sure, because 16 is a multiple of 4. What about 5? No. What about 6? No. What about 7? No. 8? Yes. 9, 10, 11, 12? No. Then finally we will have actually 16. So when it comes to common factors, we have to find out all the factors, all the divisors. Now when it comes to common, we are find out D. Now we are coming to C. When it comes to C, the common factors are 1, 2, 1, 2, 1, 2, 1, 2. And in fact, 4. What about 4? 4 is there in this number, but not in 6. Although it is in 16 also. But even if one of the numbers does not contain that factor, it can't be said common. Common means it should be present in all of the array elements. It should be a factor of all values. So 4 is not common. Then what is the G? That is greatest among all the common factors. Only 2 common factors are there, 1 and 2. They are for all of them. And the highest one among them, the greatest one among them is 2. So the GCD of all these numbers will be 2. So I hope the approach, or you can say at least the sample input and output, is clear. But the thing is how we will solve it using any kind of brute force solution. Approach 1. The approach 1 can be, we can figure out the factors of each and every number one by one. How to figure out factors of a number? We can try to divide it with all the numbers less than that or equal to that. So finding all factors of a given number will take order of the value time complexity. So let's say the value is V, where in the input the value can be at max 10 raised to power 3. So we are saying value of array element will be V. So V can be anything from 1 till 10 raised to power 3. Anything from 1 till 10 raised to power 3. And in order to find factors of the value V, we will be taking order of V time complexity. But this is just for one number. How many such numbers will be there? There will be n such numbers, that is array elements. N is the array size. So n times V, it will be total n into V time complexity. Surely it might work. Why? Because in the constraints, n is also small, V is also small. But is there any better solution? Instead of finding all the factors and then just finding the highest common factor or the greatest one which is common in all of them, better will be actually to break down the problem. So a better solution is to break down the solution. How we are going to break down? Let's suppose we are going to find out GCD of 3 numbers, A, B, C. The formula says that GCD of 3 numbers can simply be equivalent to GCD of first 2 numbers. Whatever the GCD will be, obviously it will be a single integer. Let's say it is D. So D, if it is taken the GCD with the third number, which is C, the final output will be the same. What do you mean by that? GCD of 3 numbers altogether is the same as GCD of first two numbers taken with the third number, the GCD twice times. First time for first two numbers and then the resultant of them with the third number. So if we apply this formula for the entire array, what we can do actually, we can just find the GCD in pair wise. That is, first find the GCD of first two elements. Answer will be given as an input to the second GCD function. Answer will be given as a GCD input to the third function. And finally, the answer will be the overall GCD of all the numbers. What do you mean by that? If let's say we are having these four numbers only, what will be the GCD of 4, 6? GCD of 4, 6 is highest common factor between 4 and 6. Let's actually try it from the last, because from last the answer might change. So what is the highest common factor from 8, 16? For 8, 16, the GCD is going to be 8 only, because 16 itself has a factor 8 and 8 will also have a factor 8. Then what is the answer? Answer is 8. So when it comes to these two numbers, GCD is 8. Now take the answer and do the GCD with the previous number. So what is the GCD of 8, 6? The GCD of 8, 6 will be 8 is having 6 as a factor. No, 6 is having obviously we can say 3 as a factor, but 8 is not having a factor 3. So what is the highest common factor? 2 only. So for these three numbers, the GCD will be 2 only. And then finally, whatever is the resultant, take the GCD with the last number. So GCD of 2, 4, that is the previous answer with the new number. Finally, GCD will still remain 2, and that is what we require. So pair-wise GCD, including one number at a time from the input array, will also give you the answer. But how to find out pair-wise GCD? That we already know using Euclid algorithm. So if you have not watched the video where we have discussed about Euclid's algorithm, you have to first watch it. That is, the recurrence relation GCD of A comma B will be nothing but GCD of B comma A modulus B. And this will be the code to find out GCD of two numbers. A simple code with just 2 lines. And it will find out GCD of two numbers in logarithmic time complexity, not in linear, but in logarithmic. So what will be the overall time complexity using this solution? We will be finding GCDs of how many pairs? Of n pairs, because we are taking it in pair. And how many pairs will be there? N or n minus 1. So again, n. But to find GCD of two numbers, now it is not finding factors, which will take v time. It is just order of log v time, where v is the maximum number possible in the array. So overall time complexity will be log v into n, or you can say n log n in general, which is obviously better than the brute force. So what we are going to do is, we are going to write the pseudocode using this. But before that, we will be having a function which will actually give me the GCD of two numbers. So let's just take a comma b, and in this, what we need the GCD of two numbers. If denominator is 0, remember in that question in Euclid algorithm, if denominator b is 0, just simply return a, the numerator. Otherwise, apply the recurrence relation, numerator comma denominator. What will be the next division? Next division will be denominator becoming numerator, that is b coming at the place of a, and remainder when a is being divided by b will become denominator, that is a modulus b will come at the second position. So these two lines of code will be there. And what we have to do to find out GCD of an array, we can initialize the answer with any of the integers. We can initialize the answer with 16 or with 8, with 6, with 4, any of the numbers present in the array, because GCD will never be more than any of the numbers. It will always be less than or equal to the minimum possible number in the array. So you can initialize it with any number. So let's say int answer is nothing but, set the answer as nothing but the first number of the array, that is array of 0. Array's 0th index value, array's first value, that is 0th index at 0th index. We can initialize it with the last index also. You can run a loop from left to right. You can run a loop from right to left. So run a loop over all values of array, and one by one take the GCD of the new value with the current answer, and update the answer. Update the answer as GCD of the new value, let's say val, with the current answer, that is answer, and update the answer with the same GCD value. Finally, whatever the answer will be, that is what we need to return also. That is what the overall GCD of all the array elements is. So as discussed, time complexity will be n log v, space complexity will be nothing, because this GCD function will take logarithmic space, and logarithmic space is almost constant for input numbers at max 10 is per 3. Or you can say it is logarithmic space and the n log v time. We will be doing the code of the problem GCD of array. Now, we will be doing the inline expansion. So first, we already know how to write the GCD function using Euclid. Denominator, if it is 0, just simply return the numerator. Otherwise, apply the recurrence relation and just say GCD of a comma b will be same as GCD of b comma a modulus b. If it is not the case, then we can say obviously it will be a base case. Either one of the lines will run, either the base case or the recurrence relation. But when it comes to GCD of array of all elements in the array, we have to initialize the answer with some value, not 0 or 1, but some value present in the array only. So we can initialize it with array of 0, array of 1 present at any index. So preferably if there will be only array containing two values, minimum there will be two values. So you should at least have array of 0 and array of 1 always. So you can initialize it with them without any hesitation. So that's why I am initializing it with array of 0. That is array at 0th index, the value at 0th index. Now we can run a loop over all values of array. So we can run a for each loop over all values of array using this syntax. That is for each loop having colon. And one by one, whatever the new value is coming, we will take the GCD of the new value with the current answer and update the answer itself. That is answer is equals to GCD, the function which we have already defined, of the current value with the current answer. And pairwise GCD for all the array elements will actually give me the GCD of all the array values. So let's just return the answer. Let's see what will happen for the sample test case where the values are 4, 6, 8, and 16. It should give me 2. It is giving me 2. Let's do it for corner cases. Let's say there are 10 numbers and those 10 numbers are maybe 10, 9, 8, 7, 6, 5, 4, 3, 2, and let's say 100. So what will be the GCD of all these numbers? As soon as you will say GCD of 10, 9 will be 1. So 1, 8 will be 1, 1, 7 will be 1, 1, 5, 1, 3, 2, 1, and you can say 100, it will remain 1. So answer should be 1. Because when it comes to two consecutive numbers, there is no common factor usually. So let's see it is giving me 1 or not. Yes. But what will happen if let's say all the numbers are same 100, 100, 100, 3, 4, 5, 6, 7, 8, 9, 10. It should now give me 100 only because the GCD of 100, 100 will remain 100. Let's see if it is giving me 100 or not. It is taking some time to run and it is giving correct output. Let's just submit it and see if it is working for all the test cases or not. So it is taking some time and it is working for all the test cases. And as we have already discussed in the approach video, this loop will take n time wherein is the array size, and this recursion will take log of v size where v is either a or b, or you can say array values maximum. It can be the total time complexity as n times log v, n for loop, log v for GCD Euclid's algorithm function. And what about the space complexity? Since this recursion will be taking recursion call stack of logarithmic of v in nature, so space will be logarithmic or almost you can say constant. So n log v time and log v is the space complexity. With that, we have done the problem GCD of array. We have done all the 5 milestones. We will come with a new problem in a new video. Till then, bye bye, take care.